Okay. Okay, so when you look at the data table over here, on the first column, there are these links to the videos, corresponding videos for each row. When you click on these, links, let me show it to you. It will connect you to this page that it shows the video, okay? But you have to download the video. For downloading the video, you see over here on the right top corner, there is this down arrow, and when you click over it, direct download, you click the direct download. So there will be this, Dropbox window, so you can just ignore this one, okay? And you can ignore also this one, whatever it is. It says, I think, some safety about Dropbox. So when you, as I said, when you click on this down arrow and direct download, you will be able to download the video, okay? All right, once you download the video, you will see this video in your folder, okay? The first video is A1, and now you are ready to just run tracker. I'm just running the tracker software in my computer. Let me enlarge the fonts first. Okay, so when you just drag the video and drop on the tracker will open up the video, okay? So this is the first video I just opened up. You see the cart, the rope, and the pulley, and the system over here. You can, for example, run the video. If you run the video, you see the cart will move after it's released. All right. So the next thing is that we have to do some operations on this video. First, come over this video settings button. Okay. On the video settings button, the frame rate is put as 50. You have to change it to 52, okay? Frame rate is going to be changed to 52, the first thing. Press OK. Next, you're not going to start from the first frame, okay? Taking the data of the card position. Our aim is to just take the X versus time position for this card, moving on the horizontal direction. But we're not going to start from the first frame. If you just run the tracker frame by frame, right? Let me enlarge the window a little bit. So if you run it frame by frame, you see now we are at the 11th frame and there is no motion at all. And let me enlarge this part of the video. You see this finger of the assistant. When it released its finger, the motion will start. But I am just trying to catch the frame that the finger is just released. I think this is the 14th frame. Now at this frame the finger is just released. So I'm just before that frame it is 13. So the 13 is going to be my start frame. Why? Because finger is just released. The card is just released at this frame. So again, I will come to the video settings button, and there appears the start frame, and change the start frame to 13. Okay. This is going to be different for the rest of the all different videos. You will just try to do what I have do now. What I do, try to catch the frame that the finger is just released. So that frame is going to be your starting frame. And next, what about the end frame? End frame is going to be the frame that this falling hanging mass hits the ground. Okay, Well, you have to you don't have to be very exact about this. You just seek for the frame that the hanging mass hits the ground. Well, you will see that it will hit the ground when the rope is just loose. When you see the rope is loose, that means that the hanging mass hits the ground. Just try to catch the last frame on which the rope is still taut. Okay, I think this is the frame. So this is the last frame, in the frame 76, that you will take the data values. So you will only take the data values between this frame and this frame, between the 13th and the 76. Okay, we have to do it because between these frames the cart is doing a constant accelerated motion. Okay, so once you set up this, you're fine. Okay, you're just fine, and you're ready to take the data values and come over to the starting frame, which is 13. And next thing is that you have to put your coordinate systems. For this, you just press this button, and there appears this axis, and you can put this coordinate system for this experiment anywhere you want. It's not a big deal, but anyway, I will just put this origin to the place where you see this white label on the cart. I will locate the origin to the bottom corner of this rectangular white label on the card, somewhere over here. Okay, because I will start taking the data values or tracking this card by using this white label, and I will show it to you now how to do it. So once you set the coordinate system, you can just remove it by repressing again on the button. So now the next thing is that we have to let the tracker know about the scale. And what you see over here on the rail that the cart is moving, on the rail you see these two square white labels, and between these two square white labels the distance is 70 centimeters. Okay, we just set it up that this distance is going to be the 70 centimeters, and we have to let the tracker know this. For this, you just come over this button, the button just right to the video settings, this one, and new, and choose calibration stick. Okay, once you choose the calibration stick, come over the first square white label, your mouse pointer, and press on your keyboard, press the shift button and hold it. I am just pressing the shift button now, and I will hold it. While I'm doing this, just observe, let me enlarge this, observe the mouse pointer. Okay, I am just pressed now. Now mouse pointer turns out to be a square pointer. Okay, keep holding the shift key, and come right center of the white label and press my left mouse button and make my first mark, and come over to the second label over here, do the same, press and hold it, and just mark by pressing the left mouse button the second mark, and there appears a blue line between these two marks. Okay, and let this distance to be 0.7 meters. Okay, and by doing this, I just put my scale on the video. So again, you can remove this by just repressing this button again, and the scale is ready, and everything is ready except we have to create our object, because we are going to produce some data table over here, x versus position versus time. From this data, tracker will be able to determine the acceleration of this car. So come over create button and just choose the first one, which is point mass. Okay, once you choose that, tracker will create the object, naming it mass A, but our object over here is just M2, right? You can just rename it, press on it, and come name it over here, and I will rename it as M2 because in our setup it is named as M2. So this is M2. Okay, now we are ready to auto track this card during this motion. In every frame the tracker will run the video frame by frame, but in every frame it will take the position of this card and the timing. Okay, position and timing. It will record on the table, and it will also at the same time produce X versus time graph over here. So for this, once you are over here, again bring your mouse pointer near this white label, okay, this white label on the card, and I will choose a specific point, which is the bottom right corner, which is this one. Let me enlarge it more. And this is the one, this is the part that the tracker will take its measurements, position measurements. And for this, I'm again pressing the shift button together with the control button. Now I'm holding both the shift and the control button, and you see there appears a circle sign, a circle pointer. Now your mouse pointer turned out to be a circle, and just bring it over this corner that I take as the reference point for taking the X measurements for the card, and press. I am just pressing now my left mouse button. I just pressed it. Okay, so once I pressed it, now the tracker just produced this red circle, being the center right on the bottom right corner of this white label. Okay, that means the tracker will just search for the same shape in each frame, and it will just mark its bottom right corner as the position point of this card. For each frame it will do this. Okay, now the rest is just easy. There appears this auto tracker window, and all you have to do is just press the search button. And before that, I will come over this button and check no trails, and you will see now. Let's also enlarge this plot view. When I just press, as soon as I press the search button, the tracker will run the video frame by frame, and on each frame it will mark the position according to the this coordinate system. It will mark its position, it will record this position, also its timing on this plot and also on the table. So now I'm ready, and I just push the search right now. Okay, you see these data are produced by frame, and also it is drawing all these data on the X versus time graph. So the last frame also done, and all frames that I choose, the tracker just recorded the position and also timing value for the card in each frame, and it just produced this X versus time graph, X being the horizontal direction for the video. Alright, so you see it's a kind of parabola, and obviously it's very clear from this picture. Even we haven't started analyzing yet, but it is very clear from this picture that it's a parabola, and a parabola is nothing but the position versus time plot for the kind of motion which has constant acceleration. Okay, so what's next? Remember, our job is just to calculate the acceleration for that specific video, acceleration of the green card for that specific video. Okay, we can do this both ways. We can do this either analyzing X versus time graph and curve fitting this and finding the parameters at squared plus bt plus c, and a is going to be just half of the acceleration. But also you can convert this to v velocity versus time graph. Sorry, vx versus time graph. So you see, I just pressed on the label for the vertical axis, and I can choose any physical quantity over here. If you choose vx, the velocity of the cart in the x direction, the tracker will convert the position time data to velocity versus time data. And you see, the velocity versus time plot appears to be a straight line. And well, this is what you expect for a constant accelerated motion, because for a constant accelerated motion, the velocity will increase linearly. All right, so this is something you know, and we don't need this window anymore. Just remove it. So might suggest that to calculate the acceleration, use v versus time plot, and on this plot, on this region, just come over it and press the right mouse button and choose Analyze, and there will appear this Analyze Data tool window. You again will see the v versus time plot on a larger screen, also together with the v and t data values over here. So we will analyze this plot by drawing a curve fit, a straight line curve fit, and choose this one. And now the tracker automatically draw the best line that fits this data, and it calculated just what the acceleration is. And the equation for this best equation that fits the curve, fits the data, is nothing but v is equal to at plus b. But v is equal to at plus b is an equation for the velocity for a constant accelerated motion, and in front of t, this parameter a is nothing but your acceleration. So it is calculated to be 8.621 times 10 to minus 1 meter per second square. Let me write it over here. The tracker is just calculated, and on the tracker it is just the parameter capital A, but in our case this is nothing but the small a, which is the acceleration of the car, and tracker just calculated it from here by producing this best straight line and calculating its slope to be 8.621 times 10 to minus 1 meter per second square. Okay, that's it. This is your acceleration for the first row. Okay, for the first row, that m2 is pulled by m1. Well, m1 is 50.3 grams. But you'll see that for the next one, m1 will change, but m2 is the same all the way. So m1 will change, then you will expect that a is going to be larger, but you will calculate yourself after this. I just show how to fill out this first row, and the rest is your job, and I'm just explaining what to do by just doing the first row. Okay, so but the thing is, that's not the whole story. Also, you see a plus minus delta a over here. How do you calculate delta a? Right? You have to put also the uncertainty of your calculated acceleration. So I will show it to you how to do it. Okay. We know that this is the plot for v is equal to a times t, right? There is also a b parameter over here, but since this b parameter is very small, 10 to minus 13, that means the initial velocity of the cart is almost 0. So just get rid of this, and you don't need this. So our equation for the data set that v data, which are these column, and t data, which is the first column over here, is connected by acceleration. And if you want to find the uncertainty in the acceleration, you just have to use this equation, delta A, is just A, which is this calculated value, multiplied by in square root delta V divided by V squared plus delta T divided by T squared. This is the formula to calculate delta A. And A, as I said, is just this A parameter. This value you will put over here. What about this delta V, for example? Delta V, just when you come on over here, this window that you get the best fit and the parameters, etc., you also see this root mean square deviation on over here. You see, this is the root mean square deviation. This is the root mean square deviation for this graph of the variable, the vertical axis, Vx. So this is the error or uncertainty on the vertical axis, which is nothing but V. So that means this is nothing but delta V, okay? It is delta V, and I just read over here this value, which is root mean square on this plot. Over here, it is written over here, just over here. 5 point delta V, let's say this is delta V. 5 point, sorry, this is, you cannot see because it is over the black region. It is delta V is equal to 5 point, I'm reading 5.892 times 10 to minus 3. Of course, since this is V, delta V, it is meter per second. Okay? This is the value you put over here in this equation. What about V? V is the last velocity value. The velocity value of the track on the last frame, which is this one. Okay? So we are on this graph. If you push your button over here, the last button, there appears this yellow label over here. On this yellow label, you will see the second, the second number, Vx, is the last velocity value, which is, I read, 1.020. Okay, this is 1.020 meter per second. Okay, that's it. And what about the next parenthesis? You put just these values over here, and this one here, and take the square of this ratio, okay? And plus the next one, delta T divided by T. So how do you get delta T? Obviously, you got the delta V from this root mean square deviation on the tracker on this, and the root mean square deviation on over here is just the uncertainty of the variable which shows the vertical axis on this graph. If I change this vertical axis somehow to T, okay, and I put this T axis over here, the vertical, and V axis to the horizontal. And you know what? This is something you can do on tracker. If you just come over Vx, and there appears this T over here. If you select T, voila, that's T now, and T is being the horizontal, the vertical axis, and V being the horizontal axis. But you have to put also this autofit checkbox to be checked, so that so that the tracker again fits this data baseline. So when you do this, now all this data is plotted in a different way. Only the difference is that T values are just on the vertical and V values on the horizontal. But you know what? The tracker again will calculate only the root mean square of this T axis. So you see, this root mean square value is changed with respect to the previous one where V was here. But now T is here and the root mean square value is different because this is the root mean square for T. That is, this is delta T. Okay? So delta T, I am just reading now, is nothing but the tracker again it calculated 2.1 180 times 10 to minus 3 seconds. Of course, delta t is, and this is you put over here. And this one, the denominator t, is the timing of the last data point, which is I read to be 1.192. This is 1.192 seconds. That's it. For this equation for the uncertainty in A, this is how you calculate. A from the calculated slope value for the V versus time graph, which is calculated by the tracker, you put over here, and delta V is root mean square in V, and V is the last velocity value for the last frame, and delta T is root mean square for T, and T is the last timing for the last frame, and you just plug and check all these values and calculate what the delta A is, and put this over here, the first row next to A. Okay, so this is how you calculate A over here, A and delta A. Of course, you have to also calculate and put the values for T, delta T, and F net and delta F. Right? And what is T? T is the force that moves the cart, right? That moves M2, because this is the tension in the core, and it is the only force that pulls M2 toward right, so that M2 moves as an accelerated motion. So, and what do you know about this T? Of course, it should be equal to just the mass of the object multiplied by its acceleration. Okay? But the acceleration is already calculated. Acceleration is already calculated over here from the tracker, so you can put over here the acceleration. And you know what the M2 value is this one. You put this value over here, then voila, that's it. You just calculated T and put this value over here. And next, what about delta T? Well, for delta T, what you do is, thinking that the only source for the uncertainty is the uncertainty for the T is just the uncertainty for A. So delta T is going to be just M2 multiplied by delta A. And you know what? Delta A is already calculated from here. Put this value over here. M2 is just 525.9 grams. And that's it. This is going to be delta T. Okay. All right. So, what about F net? F net is the weight for the hanging mass, right? Because the gravity on the hanging mass is the force that moves all the system, right? And we know that F net is just equal to sum of all masses M1 plus M2, both hanging mass plus the cart, multiplied by A. So that's it. You just calculate this from the calculated value of A over here. You put this value over here, and you know what the masses are from here. M1 is just 50.3 for the first row, and M2 is 525.9. Put those over here and calculate F net and put it over here on this cell. And delta F, I just leave it to you. Right? It's easy. Again, you will use delta A. All right. So this is the way. This is the way you just fill out the first row for this table, and all the rest you are going to do yourself by using for every row the corresponding video, and download it and put it onto the tracker and work it out. the way that I showed you. Okay? Any questions so far? And anyway, this video is recorded, so whenever you feel ready to start studying or writing the report and doing the experiment, video experiment, you can rewatch this video again to do everything. Well, what next is, after filling out this table, what next is just you will plot, let me put this over here, you will plot T versus A graph, okay? And for T values, these values, this column values are going to be your data values. You'll put all these T values over here. And A values are going to be put on this x-axis, so the horizontal axis. And suppose, you know, the first T value and A value produce this data point somewhere over here. And next one somewhere over here. The other one is over here. The other one is over here. And you will see that after putting all this data, again by using tracker, tracker will make a curve fit, and it will draw a straight line, and it will just calculate the slope of this by calculating the A parameter, and the slope of this is going to be just M2 value, but it is going to be experimental value of M2. This M2 value is just measured values. These are measured values by our scale, electronic scale, and this value is going to be experimental value by using the Newton's second law. And you will just make a comparison that how these values are close to each other. And you know, bear in mind that also you have to find the experimental error on the slope, and you will do this by using the techniques that I showed you already. Okay, so then you will be completing your report, and it's going to be end of your fourth lab. Okay, do you have any questions? All right. If you don't have any questions, then you know, for this week's live class, that's it. I will stop here. But for this week's pre-recorded videos, I put the conservation of energy videos. Please watch them. You can watch them either by using the UBS system or from my YouTube channel. You know this. You know, this is the content. The conservation of energy content is the content for this week, for the 9th week. And this is just the instructions for the last experiment. Okay. All right, guys. So if there is nothing else, then I will stop here, and I wish you healthy days, and I will see you till next week. Okay. So bye.